Hi everyone, this is the week 9 PowerPoint review, the second video. Just wanted to recap this slide here. Um, for this sample prescription, calculating our three curves, our base curve, our toric base curve, and our cross curve. Um, the base curve we're either going to calculate using Vogel's rule or it'll be given in the question. Uh, The toric base curve, we know we're going to use our sphere power in the prescription and subtract that from whatever base curve is given, and that will give us our toric base curve. And then our cross cylinder is simply the toric base curve plus the cylinder in the question, which in this case is minus 1 1/4. That'll give us our cross curve. Just wanted to recap some of these basics. So let's go ahead and try some examples. So an example question will read, using Vogel's rule, calculate the base curve for the following prescription, and then calculate the curves that will be ground onto the lens. So our base curve, our toric base curve, and cross curve. So step one is to use Vogel's rule to calculate a base curve, and we'll go ahead and take the spherical equivalent of this prescription, divide it by 2 and add 6, giving us a base curve of plus 5 1/4. Then we're going to go ahead and take our sphere power in the prescription, the minus 1, and subtract it from that base curve that was just calculated. And that's going to give us our toric base curve of minus 6 1/4. Then we simply take that minus 6 1/4 and add the cylinder from the prescription, and we come up with a cross curve of minus 7 1/4. So pretty easy to calculate these three curves, and a little trick to kind of make sure you did it correctly. If we go ahead and add our toric base curve to our base curve, if we add these two, it's going to equal our original sphere power. And then if we add our cross curve to the base curve, it's going to give us our second sphere power, which is the minus 1 minus 1, just transposing that. So if we add minus 7 1/4 and plus 5 1/4, we're going to get a minus 2. So one way to check yourself is just to add across and verify that you're coming up with the same values in the original prescription. So here's another example, another one using Vogel's rule. So we'll go ahead and do the spherical equivalent of this prescription plus 6 to get us our base curve of plus 14. We're going to go ahead and plug in our sphere power from the question and plug in our base curve, and that's going to give us a toric base curve of minus 5. Then we simply add that minus 5 and the cylinder from the prescription, and we get a minus 7. Here's an example of a question giving us a base curve, so we don't need to do Vogel's rule. So we simply just take that 475 and put it in its place. And then we're going to calculate the toric base curve by taking the sphere power in the original prescription and subtracting it from that base curve that's given. So our toric base curve is a minus 12, and if we go ahead and add the rest of that cylinder in to the minus 12 to get our cross curve, we'll add the minus 250 and we'll get a minus 1450. Here's another example. I want to highlight that this is in plus cylinder. So immediately what we should do is transpose that into minus cylinder, and we come up with plus 5 1/4 minus 1. And this question is specifying a base curve, so we'll just plug that in. And then we will take our sphere power of the minus cylinder version and plug it in, and then take our given base curve and plug that in. And we have a toric base curve of +3. And we simply add the rest of the cylinder, again from the minus cylinder version. So we have our +3, and then we bring our -1 over. So +3 plus a -1 gives us +2 for our cross curve. So our three curves right here. Another example, again, this is in plus cylinder. Be mindful of that. We're going to go ahead and transpose that. And when we flat transpose that, we're going to end up with a -275 -250. The axis is not really relevant, so I'm going to ignore that. So again, this question is specifying the base curve of 350, and we flat transpose to have our prescription in minus cylinder. And we're going to go ahead and plug in our variables. So our sphere power in minus cylinder is the -275. Subtract our base curve that was given in the question, and we now have a toric base curve of -6 1/4. Then we simply add in the cylinder from the question, again the minus cylinder. So the -6 1/4 plus the -2.5 gives us a cross curve of -875. So again, our three curves. Let's see another example. Again, an example in plus cylinder. So we'll go ahead and flat transpose that into minus cylinder. So we'll find ourselves with a +10 -175. And again, I'm not concerned with the axis. So let's go ahead and plug in our base curve that's given in the question. Let's plug in our sphere power from the minus cylinder and plug in our base curve that's given in the question. And we have a toric base curve of -1. And we take that -1 and we add the cylinder amount from the minus cylinder version of the prescription. And we find ourselves with a -275 cross curve. Okay, so this is an interesting example because we're essentially starting with the cross curve and working our way backwards. So they're giving us a cross curve of -350. And now we have to work our way back to the toric base curve and then back to the original base curve. So the first thing to consider is how do we typically come up with this -350? Remember, we take our toric base curve, or which is also known as D2, and we add the cylinder from the prescription. That's how we calculate this cross curve. So if we were to rewrite this formula to calculate for D2, it would read D2 equals the cross curve, which is given. Instead of adding the cylinder, you would minus the cylinder. So let's see what that would look like. We go ahead and plug in our -350 for the cross curve and subtract the cylinder that would have been added to it, we'll find ourselves with a toric base curve of -175. So from here, now that we have our D2, we can simply just use our nominal power formula, which is to solve for the base curve. And the base curve, remember, is D1. So we'll use this version of the nominal power formula and take the prescription minus D2. And if we plug in our variables, so we're going to find ourselves with a minus 1250 for the sphere power and the prescription. And our D2 we calculated to be a minus 175. So our base curve is going to be a minus 1075. So just an interesting approach to this type of question because we're going to start with a cross cylinder and essentially just work our way backwards. Um, don't be surprised if you see maybe one question like this on a practice quiz or the final. And there will be another video posted explaining one of the worksheets. And again, if you have any questions, feel free to post in the chat or send me a message. Thank you.